Hello, I'm Ron Richards, Senior Research Curator of Paleobiology at the Indiana State Museum and Historic Sites. I'm focused on understanding the life and times of Indiana's Ice Age. I assemble the evidence, that means I pulled together collections to read the bones, to reveal what's happened in the past. How do I collect? Usually we're contacted by somebody out there that finds bones. They let us know that something's been found. 80% of the time they'll donate these to the State Museum. But very often we also have to go into the field and we have to do a dig. And I don't just do this dig by myself. I need a lot of the museum people to help. And my job there is not only making sure that everybody's mapping the bones, make sure that we're screening sediments, water screening sediments, to get the remains of small animals, but I also have to be able to answer the question, why is the site the way it was? We have one of the largest and most comprehensive Ice Age bone collections in the Midwest. At the museum, we publish scientific papers on the remains, but we also have to preserve the remains and take care of them by cataloging them into a computer database. Because of that, everything has a tracking number on it, even this mastodon jaw. Many different kinds of animals were found in the Ice Age in Indiana and the Midwest. There are a lot of animals that are now extinct. A lot of the animals that are here today were still here. And there are a lot of animals that no longer live nearby. Caribou up to the north. A lot of things to the west that were here too. So during the Ice Age, we had a big, rich amalgamation of animals. Some of the extinct animals, we can look on the poster here, and we can see some of these that we find, and we have parts of all these in the museum here. We had mastodon, mammoth, giant short-faced bear, muskox, caribou, saber-tooth. All these kinds of animals were here in Indiana's Ice Age. Now, most often we find the bones in Indiana in ancient lake and bog deposits, and we find them in caves. We want to identify and understand all of the materials that we find on the bone site, not just the big bones. We want to look at soil, vegetation, pollen, seeds, snails, and all the small bones, because we want to get a comprehensive picture of what the life and times was like in the Ice Age. So we spend a lot of time on microscopes. How do we read the bones? And what do they tell us about ancient environments? Now, we can never be sure about the environmental requirements of an animal that's now extinct. We really don't know, like say, how a short-faced bear lived. We don't know how cold it had to be or how warm it had to be. We don't know the humidity. But we can be sure if we look at the small bones of animals that are still alive today. For instance, if we find remains of an Arctic shrew on the mastodon site that occurs way up in northern Canada today, then we can be sure that at that time it was much colder in Indiana. Or if we find bones of the Plains pocket gopher, which lives to the west out in the Great Plains, then we can be sure that there were a lot of dry climates and not much ground cover in Indiana when we found these bones. You can also look at other things under the microscope, and the snails can tell you, is this a land environment? Is it a water environment? Fish bones, that's obvious. You know you're in a lake. And then we look at the individual animals. If you find spruce cones on a site, like we do on all of the mastodon sites, you can be sure that the forest there was like the conifer forest, like spruce, that they find up in Canada today. a much cooler environment. So you begin to see that we look at all the components of a site. Let's look at the individual animals. Let's look at the biological profile of an animal. And the individual age. All right, you can tell how old an animal is by comparing the tooth eruption. And here you can see this is a worn tooth. It's essentially a baby tooth in the jaw of this mastodon. And right now the roots, which you can't see, are eroding away. They're dissolving. And pretty soon that tooth will just disintegrate and fall out. And the teeth behind it will move up and move forward, just like an assembly line, delivery belt. Here's a tooth in the back of the jaw that is not yet erupted. And the wisdom tooth, by the way, is way back here. It's not even formed yet. So this is one way we can tell how old animals are, is by tooth eruption. Another way is by looking at the wear, the amount of wear on a tooth. There are charts of this. So you can look at a fossil animal, and these are fossils. Let me say they're not turned to stone, but they're over 11,700 years old. By age, they are fossils, but they're not changed. They're real bone. But you can look at the wear on those and compare them with modern African elephants and understand if this was a young animal, an old animal. This is part of getting the biological profile, understanding what this animal itself was like, the individual animal. We also can look at long bones, the big femur and the humeri, and we can look at the caps on the end of the bones. Just like us today and mammals, everybody, when you reach a certain age, these caps fuse. So we can tell by these big bones how if the animal is an adult or a juvenile. You can look at, are they male or female? Well, we can look at elephants and be sure when you have a very large tusk that it's a male. And the very small tusk are females. There's not much overlap in size. And the male mastodon bones are humongous. The females are smaller. And then we have sometimes pathology. We've got some injuries. We find broken mastodon bones that have rehealed correctly and some that did not heal right, and they still are separate. See, that way you can look at the individual's health and all of those things. We also can see, if you're lucky, you can often see the season of death of a mastodon. And we've got a big tusk up on its display in the exhibit hall. And it shows, you can see the growth cycles on the tusk. And you can see that the last one was partway through the big growth in the summer. So this thing was probably a fall death. You can also look, one more thing is, you can look at the age of an animal and be very precise if you're willing to make a long bandsaw cut all the way through the tusk. And you think that you could look at the rings in a tusk and tell how old an animal is, just like you look at a tree and you count the rings. But a mastodon tusk and a mammoth tusk are different because they're a series of cone-in cones. So you have to section the other way. And I've got a good model here that shows exactly how you could read that. One last thing you want to determine for a site and the remains, what we call taphonomy. This is all the things that happened to the bones when they became buried and after they became buried. We've got skulls here that were not buried very deeply. They were in acidic soils and they disintegrated. Here's a skull that the whole top of it has been disintegrated off. And here's another one that is disintegrated all the way down. This is a natural process because remember, to become fossilized or even preserved, the bones have to be buried and they have to survive. Another thing we look at are the other marks on the bones. And we've got a lot of toe bones on mastodons that have some big chunks taken out of them. And at first you thought, well, maybe we dug them not very carefully and our trowels cut into them. But then we start seeing we've got about 6 sites with a lot of big chunks out of bones. And these are gnaw marks, probably by bears and wolves. So we can see the marks of predation on these sites. Our goal is to really understand what happened at the bone locality that made the site the way it is. Scientific study of the excavated bones to understand the past is very important in paleontology. And the best finds are used in exhibits like we have at the State Museum and programs to provide lifelong learning for visitors and viewers like you. The more we know about the past, the smarter we will be in dealing with the future, with current and future problems of changing environments, of declining wildlife diversity, and expanding human population. So that's how paleontology can tie in to the present. Thank you very much for visiting us here.